In our lesson today, we're going to take a look at identifying different pairs of lines and angles. So some of these are going to be very familiar to you and others will kind of be brand new. So let's take a look. First of all, we have parallel lines, should be very familiar. So parallel lines are two lines that do not intersect and are coplanar. So example over here, we have two lines going to remain the same distance apart. They're never going to intersect. And we are talking about two lines that are on the same plane. Next up is skew lines. This is a new term for you. Skew lines, similar to parallel. The only difference is that they are not going to be coplanar. So two lines that don't intersect, but they're not coplanar. This one's a little bit more difficult to visualize because we are talking three-dimensional. So if we take a look at the diagram over here, you can see we have the one line up here, which is kind of coming out towards you. And we have the other one here that's a horizontal line going from left and right. So you see if these two lines were to extend, they're never going to intersect, but they're also not lying on the same plane. Next up is parallel planes. So you can probably take a guess as to what this is. Very similar to parallel lines, we just have two planes that do not intersect. So you can see an image over here. So when you look at this image, you can see that the planes are obviously appear to be parallel. So the lines that are drawn in between the two planes is showing that that distance between the planes is going to remain the same throughout the entire plane. Last up is transversal. So transversal is a line that intersects two or more coplanar lines. So I have two examples drawn for you here over on the right. Notice that here we have two lines that are kind of going up from left to right. And then we have the blue transversal, which is cutting straight down through the middle. So that transversal, that line, is intersecting these other two lines that are, in this case, appear to be parallel. Our lines do not always have to be parallel, though. A transversal can intersect any two lines. So if I look at these two lines here, I have this blue transversal, which again is intersecting both of those lines. So a transversal, just any line that's going to intersect two or more coplanar lines. All right, so let's take a look at our first image and identifying different relationships based on this diagram. So if we look, A is asking for line or lines that are parallel to line AF and contain point E. So if we look at line AF, we're talking about this line right here. So we're looking for lines that would be parallel to that and contain point E. Well, right here is point E. And if you look at the lines that are containing point E, the only one really that we see, which you're going to see is parallel, is line EJ. If we were to look at, let's say, AE or ED, you're going to see that those are either going to be intersecting line AF, or in the case of ED, would actually be skew to line AF. All right, next up, looking for lines that are skewed to AF. Well, we just talked about that. So we have AF here. We know that it's not going to intersect and is not going to lie in the same plane. If I look at AE, obviously not parallel, but it is going to intersect at point A. If we were to look at EJ, which we just talked about, that does not intersect, but is on the same plane. So the line that's going to be skew is going to be line ED. And again, this is a little difficult to visualize three-dimensionally, but AF is kind of going to be behind that line at all times. ED would extend up, would never intersect, and is not lying on the same plane. Next up, line or lines that are perpendicular to AF and contain point E. Well, let's look at our reference line here again. So we have AF. We want lines that are perpendicular to that. So based on the drawing, and we kind of are going to go based off the assumption that we see. Based on this drawing, we have AE as a possibility. And really, that's the only one that's going to be perpendicular or appear to be perpendicular and contain point E. And lastly, D, we want planes that are parallel to plane FGH and contain point E. So if I look at FGH, what we're talking about is we're talking about this back plane here, this pentagon that's in the back of our figure. So we want a plane that is parallel to that, and it's going to contain point E. Well, what we know about prisms is that our bases are going to be parallel and congruent. So if we look at the other base or the other pentagon in the front here, we know that's going to be parallel to that back pentagon. Notice that the plane that we are showing here, that's blue, is also containing point E. So there's a couple different ways that we can name that plane. Remember, you need 3 letters to name it. It doesn't matter which letters, and you can go in any order that you'd like. So because we've been using A and because we need point E, I'm just going to call this plane AED. But of course, you could call it AEC or BED or CBA. Any 3 letters that are contained in that plane, you can use to name that. All right, let's continue. So let's take a look at a postulate here. So this is the parallel postulate. This says that if there is a line and a point not on the line, then we know that there has to be exactly one line through the point parallel to the given line. So when we look at our diagram up here, we see a line, L. We see a point P that's not on our line. So what we're saying is that there's only one line that's going to go through P that's going to be parallel to our original line L. Postulate 14, which is the perpendicular postulate, saying something very similar, but in this case, we're talking perpendicular. So if there's a line and a point not on the line, then there is exactly one line through the point perpendicular to the given line. So again, we have our original line L right here. We have our point P. So what we're saying is that there's only one line that goes through point P that'll be perpendicular to line L. So we'll be using these postulates kind of later on as we start moving through some things. But just remember, given one point and one line, there's exactly one line that's parallel and exactly one line that's perpendicular. All right. Moving on down, talking about some parallel and perpendicular lines here. So we have a diagram. We want to name a pair of parallel lines. Now, remember, you cannot just assume that because something looks parallel, that we're going to say that it is in fact parallel. If you look, we do have some notation here that's going to help us out. So we can see the triangle symbol here and here, which tells us that these 2 lines are parallel. So we know that AB, and I'm going to use the notation for parallel here, which is just 2 vertical lines. So AB is parallel to CD. Next up, a pair of perpendicular lines. Well, if we look, this right here is going to help us out to figure out which ones are actually perpendicular. So we see that right angle there, which tells us that those 2 lines have to be perpendicular. So we know that AB, and again, I'm going to use the symbol for perpendicular, which is a vertical line and a horizontal line underneath. So AB is perpendicular to AC. All right, now next question. Is AB perpendicular to BC? Well, I think in this case, it's pretty obvious based on the looks that it's not, but we need to explain. So is AB perpendicular to BC? Again, first of all, no, visually not going to be perpendicular, but let's talk about why. And we can't just say because it doesn't intersect at a right angle, because really, we don't know that based on what we're given. We're not given an angle measure, so we don't know if it's a right angle or not. However, what we do know, if we look at point C and we look at our line that we're talking about, AB, remember that perpendicular postulate, which states that there's only, when given a point in a line, there's only one line that's going to be perpendicular to that point and that line. So when we look at this, we already said that AB was perpendicular to AC because of that right angle. So based on the perpendicular postulate, there's no way that this could also be perpendicular because they are going through the same point, intersecting the same line. Only one of them can be perpendicular. So I'm just going to state here because of the perpendicular postulate, but certainly you can write down some more details there if you'd like. All right, moving on. So let's start taking a look at some angles that are formed by transversals. So remember, a transversal is a line that intersects two or more coplanar lines. So two angles are called corresponding angles if they have corresponding positions. So when we look at this, we're talking about kind of the same place of the intersection. So when I look at where this transversal is intersecting my two lines, I see that the angle in kind of the top right-hand corner, those are going to be corresponding angles. Next one, we have two angles are called alternate interior angles. If they lie between the two lines and on opposite sides of the transversal. So here's a transversal, here's our two lines. So we see that these angles are in between those two lines and on opposite sides of the transversal. So they're on the inside. Angle 5 is to the left of the transversal. Angle 4 is to the right of the transversal. So we call those alternate interior angles. It's also important to note that these cannot be on the same side of the lines. So we can't have both of our angles kind of on this bottom line. One angle needs to be at the intersection of the transversal and the bottom line. The other angle needs to be at the intersection of the transversal and the upper line. So whenever we're looking at these relationships, we're always going to see that where we're looking at both intersections and not the same intersection. Next up, two angles are alternate exterior angles. If they lie outside the two lines and are opposite sides of the transversal. So this one very similar to the previous alternate interior, except now we're on the outside of those two lines that our transversal is cutting through. So we are on opposite sides of the transversal. You can see angle 1 is on the left, angle 8 is on the right, and you can see that we are outside of those two lines. So we call them alternate exterior angles. And the last one we're going to talk about is consecutive interior angles. So consecutive interior angles lie between two lines and on the same side of the transversal. So because of that, another name for consecutive interior angles is same side interior angles. So you may see either wording. Just know that we're talking about the same thing, the same relationship. So when you look at these, we have our transversal. We have our two lines that the transversal is cutting through. You can see in this case we have angle 3 and angle 5, both of them being on the left side of our line, and they are in between our two lines. Now, one other angle relationship that we don't talk about often is consecutive exterior or same side exterior angles. So those would be very similar on the same side of the transversal, just on the outside of our two lines that the transversal is cutting through. All right, so let's lastly take a look at identifying different types of angles and classifying the angle pair relationship. So in this diagram, we're going to take a look and we're going to try to find all of the different corresponding alternate interior, alternate exterior, and consecutive interior angles. So corresponding angles, remember, they're going to be in the same position of each intersection. So when we look at our diagram, let's start with angle 1. The angle that would correspond to angle 1 would be angle 3, the top left of each of those intersections. And when I'm talking about the intersection, I'm talking about right here and right here. So the upper left is going to be corresponding, which is angle 1 and angle 3. Another pair of corresponding angles. If I go over to angle 2, so the angle in the top right position, angle 4 would correspond to that. And kind of moving my way around, if I go to, let's go in order. If I go to angle 5, which is in the bottom left, angle 7 is also in the bottom left, so those would be corresponding angles. And then we do have one last pair, which I'm sure you can see there. We have angle 6, the bottom right, and angle 8, also the bottom right. Those would be corresponding angles. So corresponding angles, same position of each intersection of the transversal and the lines. All right, let's take a look at alternate interior. So alternate interior angles. So remember that we're going to be on in between our two lines. So when we look at our two lines here, we know that we are on the inside and on opposite sides of our transversal. So you can see the angles that we have on the inside, 2, 6, 3, and 7 are the only ones that we're going to be considering for this. If we take a look at, let's say, angle 2, the angle that would be on the opposite side of our transversal, in between our lines, and again, has to be one from each intersection, would be angle 7. And then if we look, we're going to see that 3 and 6 will also be alternate interior since they're in between our lines and on opposite sides of our transversal. All right, alternate exterior. So looking on the exterior of our lines on opposite sides of our transversal. So in this case, we're only considering the angles 1, 5, 4, and 8. So if we take a look, angle 1, alternate exterior. So if we look, since 1 is on the top of that transversal, we're looking below. On the opposite side or outside of our lines, we see angle 8 is going to be that pair, that match. So angle 1 and angle 8. And then we do have one more pair as well. So we have angle 4 and angle 5 being alternate exterior angles as well. And lastly, consecutive interior angles. So again, remember, we're going to be on the same side of our transversal this time, but in between our two lines. So with this, if I look at, let's say, angle 2, which is on the inside, the other angle that's on the same side, but also in between our two lines would be angle 3. And then if we look at the lower half of our line, we see angle 6. Again, same side of the transversal, but in between our lines would be angle 7. So angle 6 and angle 7 are also going to be consecutive interior. Last one, real quick, just to finish up. Feel free to do it on your own, but you see that these two angles, they are in between our two lines. So here's our transversal. Here are our two lines. So we see it's on the same side of the transversal. They're both up to the right of our transversal. They're in between our lines. So we consider these consecutive interior angles. All right, that's it for our notes today, folks. Please let me know if you have any questions. Have a great day.